This is the mini lesson for 4.3. So yesterday we worked with number lines. Today we're going to use colored counters. Using a number line, we are going to determine each sum. So if I start at 0 and go to positive 3, from there I add 3 negatives, I end up back at 0. If I take 14, negative 14, plus positive 14, now I move in a positive direction 14, I'm back at 0. Hopefully we see that if I start at 0 and I go to 8, and now I go and add negative 8, so I move back in a negative direction, I get 0. So what pattern do we notice every time? We notice that our answer was 0 every single time. There's a name for this. Two numbers with the sum of 0 is called additive inverse. So addition of integers can also be modeled using two colored counters that represent positive and negative charges. One color, it's usually red, represents the negative numbers or negative charge. The other color, usually yellow, represents the positive. In our book, gray shading will represent the negatives and no shading will represent a positive. So we're going to build some models. So I'm going to look at the example. You can model the expression 3 plus negative 3 in different ways using two colored counters. We did this on a number line, so we know our solution does give us 0, but here they're showing us if we put 3 negatives and 3 positives, we can see that a negative and a positive cancels each other out. So what I have is really 3 groups of 0, so I get an answer of 0. So they can either show me 3 negatives, 3 positives, cancel each other out, or we can pair them up. This is called making 0 pairs. 1 negative, 1 positive makes a 0 pair. Another 0, another 0. So what is the value of each negative and positive pair shown in the model? And that answer would be 0. 1 negative, 1 positive always gives me 0. Describe how you can change the number of negatives and positives in the model but leave the sum unchanged. If I went up here and let's say I added 2 more negatives in here, then to keep my answer still 0, it just means I would have to have added 2 positives. These 2 pair up to give me 0. These 2 would pair up to give me 0. I could add 6 negatives, then I'd have to add 6 positives so that I do not change the outcome or the answer. So here they're going to give us some more examples now that aren't going to give us an answer of 0. So 5 plus 8, we know that this answer has to be 13, but let's make a model. If I have 5 positives and I add 8 more positives, all together, what do I have? I have 13 positives. So let's try another model. Here we're going to use negatives and positives. So I have 5 positives. I'm adding to my circle here 8 negatives. Now I need to try to get the solution. Well, I know every time I have a negative and a positive together, it gives me 0. So I can take the 5 positives and I can take 5 of the negatives. I know that gives me 0. So if I kind of remove them off of this circle, what's still left? I would still have 3 negatives left, which means my solution is negative 3. So here they would like us to create another model. So I oftentimes will call this my placemat, and I want to represent a sum of 3. That means something plus something else is going to give me negative 3 for an answer. So I'm going to see what I can come up with. So that means in the end, once I make my 0 pairs, I need 3 negatives to be left on my plate. So maybe I want to add 2 positives, which means I need to add 2 more negatives, because altogether this gives me 0 and I'm left with negative 3. So I could represent this saying positive 2 plus 1, 2, 3, 4, 5. 5 negatives, I would be left with negative 3. I'm going to do one more example. If I need to have 3 negatives left on the plate, let's say I want to have 4 positives, then I need to have 4 negatives so that all of this gives me 0. 4 positives plus 4 negatives is 0, and I'm left with -3. So what's my equation here? It's positive 4 plus 1, 2, 3, 4, 5, 6, 7, 7 negatives, and that would still leave me a solution of -3. We're going to skip 6 since if you're watching the video, you're probably doing this by yourself. We're going to write a number sentence to represent each model. Here, I see 2 positives plus 1, 2, 3, 4, 5, 6, 6 negatives. Or I could have said I saw 6 negatives first plus 2 positives. But now I want to get my solution. I know that if I put these two together, that makes 0. If I put these two together, that makes 0, so I can remove them. And I'm left with 1, 2, 3, 4 negatives. So my solution in either case would be -4. I'm going to try this one. I see 1, 2, 3, 4, 5, 6, 7 positives plus 3 negatives. Or I might have seen the negatives first, and I would see 3 negatives plus 7 positives. Either way, I can say these 3 negatives and these 3 positives, they make 0. So I'm going to match them up and slide them off. What's still left? 1, 2, 3, 4. Still left with 4 positives. Okay, at this point, I would have you guys continue the lesson in your book. But what I want to see is that once you get done with problems 13 and 14, I want to make sure that you have a good understanding of these two solutions. So pause the video, work all the way through 14, then turn the video back on and see if you have these right. Hopefully you've worked all the way through 14. Now I want you to double check these two. It says to write a rule that states how to determine the sum, that's an addition problem, of any 2 integers that have the same sign. So for example, I'm talking about a negative plus a negative, or I'm talking about a positive plus a positive. And here's what I'm going to tell you. What we should have discovered is that a negative plus a negative still gives me a negative answer, and a positive plus a positive will always be a positive. But how I get the value of it, I am going to say that I add the absolute values. So let me give you an example. Example of -4 plus -2. I'm going to give myself a box, and I know that my answer is going to be negative. To get the number portion, I'm taking the absolute value of -4, which would be 4. And I'm taking the absolute value of -2, which would be 2. And I'm going to add those two together, and I get a total of 6, so I get -6 for my answer. Here they want me to write a rule that states how to determine the sum, so addition problem, of 2 integers that have opposite signs. So here I'm looking at a negative plus a positive, or I'm looking at a positive plus a negative. So hopefully what we discovered here is that what I'm really doing to get the number portion is I'm subtracting the absolute values. And then I'm taking the sign of the larger absolute value. Okay, so let me give you an example of that. Let's try, I'm going to say -6 plus 3. So I'm taking the sign of the larger absolute value. Absolute value of negative 6 is 6. Absolute value of 3 is 3. 6 is bigger than 3. The absolute value is a negative, what started as a negative. So my answer is going to be negative. And now I need to subtract their absolute values. Absolute value of negative 6 is 6, and this is 3. And if I subtract these, I'll get the numerical version, or value. So I'm subtracting their absolute values to come up with the number. Here, I'm adding their absolute values to come up with just the number. Here, my sign will be the sign from the problem, but it's the piece that had the larger absolute value. This absolute value is bigger, so my answer is negative.